Hey math kids, today we're going to talk about the binomial theorem, and this is what it is. It's a way to expand things written in this form. And so we're given this on the first question, and they want us to write the first three and last two terms. Okay, so what we're going to do is just plug this in, and so the first three terms are going to correspond to r equals 0, 1, and 2, and the last two terms are going to be r equals 11 and 12. So we just plug it in. So we're going to plug in n. So n is just whatever the exponent is. So we get 12, and then r starts off at 0, and then we have a raised to the n minus r, and then our a is 2x, and that's raised to the 12 minus 0, and then the b is 1 over x, and that's raised to the 0. Now they say not to simplify. There's a lot of stuff we could do to simplify here, because this actually simplifies just to 2x raised to the 12. But they told us not to simplify, so we're not going to do that. Okay, so this is the first term. Now the second term, we're going to, our n is fixed, but our r is going to move up to a 1. 2x, 12 minus 1, and then 1 over x, and 1. Okay, so this is term 1, term 2, but r equals 0, r equals 1. Alright, then we're going to add the next one. We get 12, 2. This is a combination, by the way. I should probably point that out. So this is the same as saying 12C0. This is the same as saying 12C1. And so we would have to do, like on a problem where they want us to simplify, we'd actually have to figure that out. 2x to the 12 minus 2, 1 over x raised to the 2, and we're done with that term. Then dot, dot, dot. So this is our third term. Now dot, 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 and we're going to go to the last two terms. So we're going to do r is 11, so 12, 11, and then 2x, 12 minus 11, 1 over x to the 11th. So this was r equals 2. This is second to last. Which is r equals 11. And we'll go down one more. 12, 12. 2x raised to the 12 minus 12. 1x raised to the 12. So this is the last term when r equals 12. Okay, so that was just kind of an exercise to help you see how all of this is used. Kind of long, right? But yeah, not too bad. So we'll get rid of this stuff and try a new one. Okay, so we need to find the seventh term of 3x minus 4 over x squared to the 14th. Okay? And it says do not simplify your answer. Okay. So remember we start at 0, so it's 0, 1, 2, 3, 4, 5, 6 would actually be the 7th because we go 1, 2, 3, 4, 5, 6, 7th. So our R value is going to be 6. We know our N value is 14. A value is 3x, and B is negative 4 over x squared. So all we need to do is plug it into this thing. So we're going to get 14, 6, A is 3x, raise that to the n minus r, and then our B value is negative 4x squared, and we raise that to the r, which is 6. Okay, and that's it on that one. Okay, the next one, we start with x squared plus 4 over x, and raise that to the 12. So it wants the coefficient, so part A wants the coefficient of x to the 6. Okay. And then it wants the constant term for part B. Okay. So what we're going to do, we're going to write down our A value, which is x squared, our B value, which is 4 over x, and our N value, which is 12. Now, if we want to get to like the next term that we're looking at, so if it's like t of r plus 1, we're going to do 12 in this case because that's n, and then we have r, and then we have x squared to the 12 minus r, and then we have 4 over x, and that's raised to whatever r is. Okay. Now, we can simplify this if we need to. It might make it easier, so let's do that. So with our exponent rules, we're going to distribute a 2 right there. So it's x to the 24 minus 2r. And then we can distribute an r to each of these. So it can be 4 to the r, x to the r. You can think of that like that. Alright. Now, if we think of this as just one big fraction, I'm going to pull the 4 to the r out in front. And then we just have this minus this with our exponent rules. And so if we just subtract another r from that, it's just going to be x to the 24 minus 3r. Okay. Now, in the first one, if we want this coefficient right here to equal a 6, we just set them equal to each other. So we just say 24 minus 3r equals 6, minus 24, negative 3r equals negative 18, divided by negative 3, and r is equal to 6. Okay. So, when r equals 6, we plug it in here, that whole thing goes to a 6. So we have, let's see, let's just go down. Okay, So we can modify this. We can say 12, 6, 4 to the 6, x to the 6. Because we already set that equal to 6. Okay, so we need to find the combination for this, which is going to be 12 factorial, 6 factorial, 12 minus 6 factorial. If we do that, this is really just a 6 factorial. So we can say 12, 11, 10, 9, 8, 7, 6 factorial. And we have two 6 factorials on the bottom. Cross those out. This 6 factorial is really like 6, 5, 4, 3, 2, 1. And we can kind of play around with these to cancel whatever. If you just want to multiply these in a calculator, multiply these in a calculator and divide, you're welcome to do that. But I think I'm going to do like 2 times 4 is 8. Can I do anything else? The 6 and the 12 would leave a 2. The 3 and the 9 would leave a 3. 10 and the 5 would leave a 2. And then dividing by 1 doesn't really do anything. So 2 times 11, 22. 22 times 2, 44. 44 times 3 would be, what does that give us? 44 times 3. $132. So this thing goes to 132. And then if we multiply that by 4 to the 6 in a calculator, we get 3,784,704. So that would be the coefficient in front of x to the 6. Now, they ask us for the constant term, so we're going to approach it the same way. We're going to look at this, but on the constant term, this is a 0. So we say 24 minus 3r is equal to 0. I'll add 3r onto that side, divide by 3, and so r is equal to 8. And then we will go through the same process. And so plugging in 8, 12, 8, 4 to the 8, x to the 0. So this just goes away because it's just timesing by 1. If we set up 12 factorial over 8 factorial, 12 minus 8 factorial, and we figure that out, if we take that number, multiply it by 4 to the 8, then we get this number. And that would be our constant term.